Hello everyone, and welcome back to another GIS tutorial video. And in this video, we're going to talk about three more approaches to generalization. In specific, we're going to talk about collapse, merge, and refine. Collapse, merge, and refine. Now, these three kind of make sense to go together because just like with amalgamation and aggregation, we're trying to accomplish the same general goal, which is to essentially remove features and replace them with something that is more simplified. In the case of collapse, we're going to be removing the feature entirely and using a symbol. In the case of merge, we're going to be sort of combining features together, similar to amalgamation, but more so dealing with line features. And then in refinement, we're actually going to just be removing some features entirely, typically based on some sort of an attribute or a threshold of size. Right? And so to sort of put that more succinctly, right, with collapse, what we're doing is we're actually going to remove features and replace them with stylized symbols. Right. And so a good example of this would be at a large scale. Again, we always, when it comes to generalization, typically we start off at large scale, right? And so in a large scale data set, right, maybe we have, right, maybe this is the school building footprint. Right, because we can get GIS data with specific building footprints. So in this case, at the large scale, right, we have a polygon that represents the building footprint of a school. But as we transition to, right, small scale, right, maybe we zoom out from a city map to a state map, rather than having this polygon doesn't make a lot of sense, right? Instead, we replace the polygon, right, maybe with, I'm going to do my best to draw here, right, a point symbol that looks like a school. Right, so we've gone from this polygon outline here to a single point, probably in the middle of the geometry, right, that looks like a school. So it's visually intuitive. Hey, this is a school, right? And this would go in the legend as well. But we've gone from the complexity of a polygon footprint, right? Or maybe we have a lot of lines that represent the intersection of a train or something like that, right? To a symbolic representation of what that would look like. So we're no longer communicating as much critical geometry information. More so, we're representing the location sort of abstractly with symbology. So hopefully that makes sense. Merge kind of does the same thing, right? So merge is actually very similar to aggregation and amalgamation, but it's the idea that we are going to, right, sort of combine lines together, right, to reduce the number of lines and the overall, right, congestion and complexity, right? So maybe we have something like a rail yard, right? So we have something like this, and then off this we have, right, all of these other, right, we have like these three going this way, and we have maybe these three, right, going this way. And if we transition to a small scale, right, we can imagine just like before when we had these examples, right, that these lines are going to be basically on top of each other. So instead, what we might do is we might do something like this, where we have this line, right, and this line. So keep in mind, because this is going to be different than when we talk about refinement here in a second, right, but these are, right, these are representations. Averages are representations of the original. Right, this line here, let me switch to a highlighter if I can. Right, I guess this line here, right, is not this line here. These are not the same line. Let me. Right, this line here rather would be the average of these three, or some other way of combining those three. Right, that's why they call it merge. We're merging them together. Right, so this represents the average or the concept, right, that we have train tracks coming off going this way. Whereas here, right, this was the actual real world representation of having three tracks. This is an abstraction of the idea that we have tracks going off this way. Hopefully that makes sense, because it is in contrast, right, to the idea, our next idea of generalization, which is this idea that we have refinement. Actually, let me zoom back up just a little bit so we can compare. Right, so this was merge. Right, in contrast, we have, right, refinement. Now, I'm going to do my best to differentiate these. But with refinement, right, let's say we have a stream data set, right? And in that stream data set, right, we have the big main stream, right? And then off of the big main stream, right, we might have, say, right, a couple of secondary streams, right? And then off of those secondary streams, right, we would have, right, a bunch of sort of tertiary streams, something like this maybe, right? So if you ever look at a stream data set, right, you would definitely recognize this sort of branching pattern, right? It almost looks like a tree. Right, where the green lines fill into the blue lines, fill into the red line, right? Now you can imagine if we zoom out to a smaller scale, right, these green lines would just become a mess. So what refinement does is rather than combine lines together, it filters or selects, right? Hopefully everybody's familiar with the idea of select by attribute, right? Features to be removed. Right, and so when we zoom out, right, when we go to a smaller scale, right, we would maybe keep the red lines and the blue lines, and I broke the scale here, but right, to kind of illustrate, right, we've removed the level 3 rivers, right, the green, because they would have created too much congestion. We've simply elected to remove them from the data set in order to have a better symbology. And again, I accidentally broke the scale here, right? That it would make more sense, these would all be much closer together. But the idea here, the core concept with refinement, is that we are actually actively removing features. So rather than with merge, where we're combining things together to create average abstractions that aren't representative of the original data necessarily, right? With refinement, we're actually just removing things. So this blue line here, right? This blue line here is this blue line here, right? They're the exact same data. Versus with merge, right? These three lines became this line through some sort of geometric average or something. So with merge, right, we've broken the geographic reality. Whereas with refinement, we've kept it by simply removing some of the data that meet some sort of a criteria. So hopefully that critical difference makes sense. And as always, if you have any questions, please reach out. Thank you.